So I am just solving one example. This is the question: find Laplace transform of f of t, where it is t when t is between 0 and 4, and it is 5 when t is greater than 4. So this is the example. So answer, how we are going to solve. So we have a definition of Laplace of function. So Laplace of f of t, the definition is this: you have integration 0 to infinity e raised to minus st dt, and whatever function at here, so we will write over here f of t. But at here your function is divided into two parts, since your limit here, your limit starts from 0 and it goes up to the infinity. Between 0 and infinity there is a halt, so you have a halt at 4. So here the number 4 and here it is halt. So between 0 to 4 you have function value is t, f of t is equal to t, and in between this after 4 the function value is 5. So means we have already the property of improper integral. What is the property of improper integral? Suppose you have an integration a to b f of x dx, then and this is equal to integration a to f of x dx c plus integration c to b f of x dx for any number c between a and b, So we can do this, means the original integral will get split into the two integrals. At here basically two integrals, it may happen that you may have a breakage of the function in terms of three functions, like the first one is at here, second one is at here, another third one is at here. So it may happen. So now, but at here it will be just two breakage. So your original function f of Laplace of original function f of t will be equal to break into two integrals starting with 0 and halt is at 4. So 4, and then e raised to minus st, and this dt is as it is, and your function, what is my function? So function is t between 0 to 4. Similarly your second integral integration 4 to infinity, and between 4 to 18 infinity we have to write down the function definition. What is the definition of function? It is 5. So this is what happened, and now you can solve these integrals. So what you can do, you can write this as a integral number 1 I1, and the second is an integral number 2, that is I2. You can solve each integral separately. So let I1 is equal to integration 0 to 4 t e raised to minus st dt. Solve this integral. So how to solve this integral? So now at here we have u into v rule. So there is a product of two functions, so we can use u into v rule. What is a u into v rule? So better you use Leibniz rule. You all must have learned that Leibniz rule in the semester 2. If you have the product of two functions whose integration needs to be find, so you can have first function as it is, integration of second function minus times, then first function derivative increases and second function integration increases. So third term will be first function second order derivative and second function third order integration. So in that way you can handle this situation, provided the first function provided here the first function is always algebraic, and the second function is either exponential or trigonometric. So this is the thumb rule for using Leibniz rule. So we can use this Leibniz rule at here. So it will become, integration will be as it is. So we'll use this. So here the first function is 1 is my first function, and this is my second function, as we have decided over here by the rules. So first function is as it is, I have to write. So t I will be writing as it is. Second function integration, so e raised to minus st, integration e raised to minus st divided by minus s. Then next is minus sign, which is a natural, and then first function derivative. So t derivative with respect to t, that is 1, and then second function integration. So here while finding the integration, handle carefully, this is a constant term, so I will write minus 1 by s, which is a constant, and so we have to write the bracket over here, and then beside it's the integration of e raised to minus st. So integration of e raised to minus st is e raised to minus st upon minus s, and then we can have the limit between 0 to 4, and now we can substitute that limit. So at a place of t we have to write 4. So here is 4, here is e raised to minus 4s upon minus s, minus, or you can simplify first. So minus it become minus 1 upon s square, and this is e raised to minus 4s. This is the upper limit for 4. Next is minus times the lower limit, so we will put 0. So 0 into t, so we will have 0 at here, minus 1 upon s square, and here it will be e raised to 0. So simplifying this stuff, so we will get minus 4 e raised to minus 4s upon s, minus 1 upon s square e raised to minus 4s. This minus will become plus, so plus 1 by s square. So this is what happened. This is what the first integral value. Now similarly we have to solve the second integral, I2. So let I2 is equal to integration 4 to infinity 5 into e raised to minus st dt. So we'll solve it. So it is equal to, so now phi is constant, will come out of the integration. So here we'll have 4 to infinity, and this e raised to minus st will remain as it is, dt. Now the integration of e raised to minus st. What is the integration of e raised to minus st? This is 4 e raised to minus st integration. So e raised to minus st integration is e raised to minus st upon minus s, and the limit 4 to infinity. So 5 minus 5 upon s is a constant sum, e raised to minus st. Instead of that we will be putting 4 by infinity. So minus 5 upon s, and here we will write down e raised to minus infinity, and then minus times e raised to minus 4s. So e raised to minus infinity, we know that it is 0, so it will be minus plus 5 by s e raised to minus 4s. So now you can write down your Laplace of original function f of t, that is I1 plus I2. So togetherly you can write down the I1 of first answer, that is minus 4 e raised to minus 4s upon s, minus e raised to 4s upon s square plus 1 by s square, and then here plus 5 by s e raised to minus 4s. So this is how you have to tackle the situation. So this is very important. You see that this is original function, since it is divided into two parts. So such function is called a piecewise continuous function. It is continuous in this piece and also continuous in this piece. So in piecewise continuous function, the integral by the property of improper integral, the integral will divide into the number of parts that the function is divided, and so solve the integral. So I hope you have understood